Hello guys, I'm Elisa. Today we're going to learn how to simulate the price of exotic option under Black-Scholes risk-neutral framework using different models. Firstly, what is Black-Scholes model? The Black-Scholes model is a widely used option pricing model that is based on the concept of risk neutrality. The risk-neutral framework is a fundamental assumption in the Black-Scholes model that simplifies the pricing of options by assuming a risk-neutral market environment. The formula of underlying asset under risk-neutral measure is St equals to S0 exponential r minus delta minus zero point 0.5 sigma square times t plus sigma zt, where S0 is asset price at time zero, R is continuous compounded risk-free rate, delta is annual dividend yield, sigma is volatility, T is time in years, Zt is z-score for normal distribution, which the mean equals to 0, sigma square equals to T. To understand the pricing of option, we must first understand the payoff of call and put option, where the general payoff of call and put option is maximum St minus K, otherwise 0 for call option, and max K minus St, otherwise 0 for put option. The pricing models we are introducing today are Monte Carlo simulation and binomial tree model. Firstly, what is Monte Carlo simulation? Monte Carlo simulation is a computational technique used to model and analyze uncertain or complex systems by performing repeated random sampling. It is named after the Monte Carlo casino in Monaco, known for its game of chance. So the steps to construct a Monte Carlo simulation is first to define the problem. Identify the system or process you want to study and the variables involved. In this case, we are focusing on the pricing of the option where the variables involved follow Black-Scholes framework. Secondly, define the input distribution. Specify the probability distribution or ranges for the uncertain inputs. These inputs can be randomly generated based on known statistical probabilities, such as normal, uniform, or exponential distribution. To simulate the price, normal distribution is used in our model. Next, thirdly, generate random samples and run the simulation. Use a random number generator to generate a set of random samples for each uncertain input variable. The number of samples depends on the desired level of accuracy and precision. And then we will run the simulation through the defined equation or algorithm. Fourth, analyze the result and draw conclusion. This can include estimating probability, assessing risk, optimizing decision, or evaluating the impact of different scenarios. After obtaining some basic knowledge of Black-Scholes model and Monte Carlo simulations, we are going to test our understanding with CBT question 5. So, assume a stock price process follows the Black-Scholes framework. It is given that risk-free interest rate is 6% per annum continuously compounded, stock price volatility is zero point 0.2 per annum, T equals to 24 months, which is 1 year, which is 2 years, sorry. S0 equals to $29 and the stock does not pay dividends. The exotic option delivers 2,000 shares of the stock if and only if the stock price at time t ST satisfied, which is greater than $33 and less than $36. Determine the price of the exotic option by running a 200,000 Monte Carlo simulation in Excel. If you are familiar with option pricing, it is not hard to observe that the payoff of this exotic option is similar to asset or nothing call, with strike price of 33 minus asset or nothing call with strike price of 36. The payoff of general asset or nothing call is ST if ST less than K, which is the payoff of the put option. Payoff of call option is ST if ST is more than K. So, but in the case of Q5, the option delivers 2,000 shares of the stock if the stock price falls between 33 and $36. There will be no payoff if the price is less than 33 or more than 36. So the payoff of the option is 2,000 ST if ST more than 33 minus 2,000 times ST if ST is greater than 36. So there will be no payoff after $36.
To determine the price of the exotic option using a Monte Carlo simulation in Excel, you can follow these steps. First, we need to set up our Excel spreadsheet with the necessary inputs and formulas. So, we key in the information given in the question in the Excel sheet. S0 will be 29. The time to maturity will be 2 years, volatility will be zero point 0.2, dividend yield will be 0 since it's a non-dividend paying stock, risk-free rate will be 6%. So firstly, we use the sequence function to generate a 200,000 steps. And then for the z-score, we use norm inverse to generate our z-score. Inside the function of norm inverse, we use ran bracket function to generate random numbers between 0 and 1. Since we already know the formula to calculate the stock price under Black-Scholes framework, we key in the formula in S2. So the formula will be this one. And then next we use an if statement to determine the payoff of the option based on the stock price. If the stock price is between $33 and $36, the payoff is calculated as 2,000 times stock price. Otherwise, the cell is left blank. Then we will need to sum all the payoff of the option using the sum function in Excel and then divide it by 200,000 steps to get the expected payoff at time 2. Lastly, we need to multiply the average payoff by a discount factor to account for the time value of money. In this case, our discount factor will be exponential negative RT. The result will be an estimate of the price of the exotic option based on the Monte Carlo simulation.
Now, we are going to learn another model that is often used in option pricing, which is binomial tree. Okay, what is binomial tree? Binomial tree is a visual representation of the possible price movement of an underlying asset over time. It is commonly used in financial modeling, particularly in the context of option pricing and risk analysis. So this is the visual of binomial tree. And then here is some important element of binomial tree. Time and discretization. The time period is divided into smaller interval or steps, typically referred to as time steps or periods. Each period represents a specific length of time. Upward and downward movement. At each time step, the underlying asset can move either upward or downward. The magnitude of the upward and downward movement is determined by a parameter called the up factor and the down factor. Probability calculation. At each time step, the probability of an upward movement and downward movement is calculated from the risk neutral assumption. The price calculation. Starting from the initial price of the underlying asset at time 0, the binomial tree is constructed by calculating the possible prices at each node for each time step. The price at each time node is determined based on the upward and downward movement and the initial price. So option valuation. Using the binomial tree, the value of an option at each node is calculated based on the underlying asset's price and the risk-neutral probabilities. The option value at the final nodes represents the estimated value of the option at expiration. Backward calculation. The option values are calculated backward, starting from the final nodes and moving towards the initial nodes. At each node, the option value is determined by discounting the expected future payoff using the risk-free rate. Here is some important formulas to remember in order to construct binomial tree. Firstly, mu equals to exponential r minus delta times h plus sigma square root h. Down factor d equals to exponential r minus delta times h minus sigma square root h. And our p, which is probability of upward movement, equals to exponential r minus delta times h minus d divided by mu minus d. And then we have probability of downward movement, which is just 1 minus p. Now we are familiar with the formula of how to construct a binomial tree. Let's look at CBT question 7. Tamara Mellon, a London-based fashion designer, is expecting to receive 100 million from a Japanese company as payment for goods sold in 1 year. Concerned about the potential exchange rate fluctuation, the company decides to hedge its currency risk by purchasing an option that grants the right to exchange yen for pounds at a rate of 0.0055 pounds per yen, given the following information. The spot exchange rate is 0.005 pounds per yen. The volatility of the exchange rate between the two currencies is 0.08. The continuously compounded risk-free interest rate for yens is 0.055. The continuously compounded risk-free interest rate for pounds is 0.035. You are required to calculate the cost of hedging using a 12-period binomial tree using two distinct approaches, pound-denominated and yen-denominated. To calculate the price of the option by conducting a Monte Carlo simulation of 100,000 iterations using Microsoft Excel. For this task, assume that Black-Scholes framework is applied to the currency exchange rate. To solve this question, we must understand the concept of currency option. A currency option is a financial derivative that gives the holder the right to buy or sell a specific amount of one currency in exchange for another currency at a predetermined exchange rate, which is the strike price, on or before a specific date, the expiration date. It provides a way to manage the risk associated with fluctuation in foreign exchange rates. Here are some key points to understand about currency option. Underlying currency. A currency option involves two currency, the base currency and quote currency. The base currency is the currency being bought or sold, while the quote currency is the currency being exchanged for the base currency. In this example, the base currency in pounds denominated market is yens, and pounds are the base currency in yens denominated market. Call and put option. A call option gives the holder the right to buy the foreign currency and sell the denominated currency, while a put option gives the holder the right to sell the foreign currency and buy the denominated currency. The pound denominated market, we are exchanging yen for pound, which is a put option. In yens denominated market, we are exchanging yens for pounds, which is determined as a call option. So spot exchange rate is the current exchange rate between the two currency at the time of the option contract. The strike price is the exchange rate at which the option holder can buy or sell currency. It is predetermined and specific in the option contract. The expiration date is the date at which the option contract expires. After this date, the option is no longer valid. The premium is the price that the option buyer pays the option seller for the right to buy or sell the currency. It represents the cost of hedging. The currency option can have different exercise styles, such as European style or American style. European style option can only be exercised at expiration, while American style option can be exercised at any time before or on the expiration date.
After we gain some understanding of the currency option, we can start constructing our binomial tree. Firstly, we set up the necessary input parameters. The spot exchange rate given in the question is the S0 for pounds denominated market, which is 0.0055 pounds per yen. And the strike exchange rate is 0.0055 pounds per yen. Time to maturity is 1 year, which consists of 12 period. So our period length H here is 1 month, which is 1 over 12 year. Volatility is 0.08. Risk-free rate is 0.035. And we are earning from the foreign rate, so our delta here is 0.055. After that, we calculate the up and down factors for the binomial tree using the formulas below, which is this one. Mu equals to exponential r minus delta times h plus sigma square root h. Down factor equals to exponential r minus delta times h minus sigma square root h. Our p, which is probability of upward movement, equals to exponential r minus delta h minus d divided by mu minus d. So our probability of downward movement equals to 1 minus p. Then we set up the binomial tree structure by creating columns for each time step and calculate the prices at each node of the binomial tree using the up and down factor, which price at each upward node equals to S0 times up factor, and price at each downward node equals to S0 times down factor. And then we fill the formulas to the right until the 12th period. So we are able to observe the exchange rate at the maturity. Next, we calculate the option values at each terminal node of the binomial tree based on the payoff. In this case, we are exchanging yens for pounds. So the option referring here will be put option. We use max function to calculate the terminal payoff, which is max k minus st, otherwise 0, and then times the payoff with p or 1 minus p depending on its movement. We sum all the payoff and discount back the payoff with exponential minus RH to get the option price at the respective time step. We keep repeating the steps to the left column until time 0 to get the put option price at time 0. Lastly, times the option price with the number of yens we are exchanging, in this case 100 million, and we are able to find the cost of hedging in pounds, which is 59,216.3. For the cost of hedging in yens denominated market, we repeat the same thing as we did for pounds denominated market. However, we need to amend the S0 and K since the currency is in yen now. We use 1 over 0.005 to get the spot exchange rate and 1 over 0.0055 to get the strike price in yens. Next, we also need to reverse the risk-free rate and foreign rate here, which risk-free rate is 0.055 and foreign rate is 0.035. For mu d, p, and 1 minus p, we are using the same formula as above, then we repeat the same steps to calculate st. Next, we calculate the option values at each terminal node of the binomial tree based on the payoff. But then, in this case, we are exchanging yens for pounds, so the option referring here will be call option since it's yens denominated. We use max function to calculate the terminal payoff, which is max st minus k, otherwise 0. The rest of the steps are just the same. After we get the call option price, we need to determine how many pounds we are exchanging, so we divide 100 million yen by the strike price and times it with the call price to get the cost of hedging in yen. Next, for question B, we need to calculate the cost of hedging with Monte Carlo simulation. This question is similar to question 5. I decided to calculate it with pounds denominated approach because it is much more straightforward. We copy-paste the parameter from the previous sheets. Again, we use norm inverse to generate our z-score. Inside the norm inverse function, we use rand function to generate random numbers between 0 and 1. Then, we calculate the stock price using Black-Scholes formula here to find S1. The payoff of the put option will be max k minus S1, otherwise 0. And then we sum all the payoff and divide the payoff by its total steps to get expected payoff. Then multiply it with the discount factor to get the estimated put price. Lastly, we find the estimated cost of hedging in pounds by multiplying the put price with 100 million yen.
So, in conclusion, the binomial tree approach is computationally efficient and provides insight into the potential outcomes and risks associated with options. However, it is a simplified model that assumes certain assumptions, such as constant volatility and risk-neutral probabilities. Other more complex models, such as Black-Scholes model or Monte Carlo simulation, may be used for more accurate pricing and analysis in certain situations. That is the end of my presentation today. Hope you find it informative. Thank you.